Hello, this is Mr. Huff, and I want to talk briefly about using Excel for analysis. And I'm going to do kind of an overview, show you how to make a couple of charts, how to throw trend lines in there, talk about best fit lines and that sort of thing. And then we're going to look at a couple of problems that would use that kind of information. So first we are going to go to Excel, and in this data table, or in this workbook, I have recorded some data. What we did with this is we took a golf ball and we rolled it across the room in a really consistent manner, measuring how much time it took to get to certain points throughout the room. So you see the first column here, column C, is the different times we took, and distance is how far it was when that time occurred. So we went to 11 feet, 23 feet, all the way to 41 feet. So a little bit about Excel. When you make a data table, the column that you want to include first is the independent variable, the one you're controlling. And if you're not sure and time is one of your variables, it's usually time that's going to go in your independent variable. And then the second one is going to be the dependent variable, or the responding variable, the one that you don't control, the one that you're measuring to see how it responded. So time and distance doesn't really make sense so much here, but if you're setting this up for like a science lab, always put your independent first, and that way it will always go on the x-axis. Okay, so let's make some graphs. The first thing I need to do is select all of this data, and then I'm going to go up here and click on the word Insert. I'm going to find the scatter plot icon right here and click on it, and I choose the top left choice, the one that just has the dots. Okay, and you'll see that it makes a nice little chart here based on this data. And one of the problems I already have is that this doesn't have axis labels, so you don't know what these numbers mean. So we're going to click on the little plus next to the chart and check axis titles. And then we're going to go in here and change these. So I'm going to make this one is my y-axis, and that's going to be the distance. And the x-axis is my time. So I'm going to double click that, and so we're going to make this one time. Now I have the labels put in properly. I'm going to point at one of my data points, and then I'm going to choose right click, and it's going to pop up this little menu. The thing I'm interested in is right near the bottom. It says add a trend line. I'm going to choose that. And it's going to guess what kind of a line it needs to put in here. In this case, it's guessing that this is a linear function. And if we look at this, it makes sense. So most of the stuff we will do this year is going to be linear. So if I go to the bottom of this, we have to ask well, let's go ahead and check the things I know I'm going to check. I'm going to display R square value on chart, and I'm going to display the equation on the chart. And you can see right here, I have an equation and an R square value. But there's one other thing we need to think about. Oh, let me get back here. One other thing we need to think about: does this line intersect the origin? And in this case, at 0 seconds, we had 0 feet. So we're going to set the intercept to be 0, 0. So always check the bottom two, and you have to ask that question, set intercept to 0, before you do that. If you can't say at 0 seconds it was 0 feet, then you cannot check that. Alright, at that point I am done with my graph here. And if we look at this a little bit, let's talk about these numbers. I'm going to make them a little bit bigger by increasing the font size, so you can see them easily on the video. So it says y is equal to 6.4929x. And if you think about the slope-intercept formula, y equals mx plus b, where m is the slope and b is the y-intercept, we can see that this is telling us the slope. So 6.49 is the slope of this trend line, and what that means is that is the change in y over the change in x, or the change in distance over the change in time. Distance divided by time is a velocity or a speed. So this slope is telling us the speed of the golf ball the whole time it was moving. R square value is, the technical name is the coefficient of determination. Another way to describe it is the goodness of fit. And really what it's telling us is how well this line matches these data points. And I like to think about it like a grade. If I had a grade of 96, I'd be pretty happy. That's pretty good. If it was 1, that would be a 100% fit, and all of these dots would be exactly on this line. And if it was less than about 0.85, I would start asking questions if that line is meaningful or not. And if it gets down to like 0.5, there's not really a strong relationship there. So in the high school science class, you're normally going to see high 80s and even into or high 0.8s and approaching 1 in some cases. But that kind of tells you about the quality of your line as far as how it represents that information. Let's do it one more time just so we can see it. So I have another set of data that we want to analyze. This is bicycle data, and this is going to be something you're going to analyze for me and answer some questions for. So here's some bicycle data. In the assignment I've posted on Canvas, it's all there. So I put the bike weight first and the height second. I'm going to highlight that data and then choose Insert, Scatter Plot, and choose the top left one. And then in this case, I have a little bit different looking chart, don't I? I have data that obviously is not going to intersect 0. So first thing we need to do is add in our axis titles. So I'm going to do that real quick. Okay, now that we've got our axis titles in there, we're going to point at one of the data points, right click, add a trend line, linear. We do not set slope to 0 or the intercept to 0, but we do show the equation and we do show the R-square value. Let's kind of discuss what this is telling us. So think about the y-intercept formula or the y formula, slope-intercept formula, that's what it is. Y equals mx plus b. So we have the slope, which is height divided by weight, and b, which is the y-intercept, which means if you follow this line all the way back to 0, it should be, instead of like 90 is where this graph ends, it would be way up here like 155. Okay? So this formula tells us how many inches you lose, that's a negative number, how many inches you lose of height every time you increase the weight by 1 pound. That's what that is telling us. And if we look at the R-square value, this tells us that the line that we just added is a good indicator, a good fit for that series of data. So we can confidently make some predictions with this data. So that's just a real quick introduction to how to use Microsoft Excel to analyze data. This is called regression analysis. If you start using this in your science class, you'll so impress your teachers, I'm sure.